So now I want us to work out how to find the greatest coefficient when we have x and y as well. So up until now, it's just been the coefficient, but what about when you want to consider x and y? Well, it's actually quite simple. The questions will tell you what x equals to and what y equals to, and all you need to do is substitute those numbers into this equation here. Yeah, so instead of b on a, it's just now by on ax. So that's quite simple. Now the other thing is the term numerically greatest coefficient. So what that means is that, for example, if you had ax minus by, then your values would be plus minus plus minus. Now when a question asks you for the numerically greatest coefficient, it means it doesn't take into consideration the sign. That means that -6 is greater than 5 when we're considering numerically greatest coefficient. Yeah? So, for example, if I had -100 and 99, and I want to the numerically greatest coefficient, so which one would be bigger? Exactly. The -100 would be bigger, yeah? Because no consideration of sign. All right, so just keep this in mind of when we're working with x and y's, all you need to do is just sub in the values of x and y into that equation there. So let's start off by having a look at question 5. So here we want to find the numerically greatest coefficient in this expansion for x equals to 2. Yeah? Can you see that? So it's telling you what the x value is. So we're going through exactly the same process. So we want to find out the ratio greater than 1. All right? Now remember, the ratio equation is given to us by n minus k plus 1 on k multiplied by b on a. Now n in this case is 8. B will be 2, and then A will be 3. The only difference is now that we have B times that x, yeah? And this is when we substitute in this number. So this x equals to 2, this becomes 2 times 2. And that value is substituted into there now. All right, can you see that? Good. So that's really the only difference that you do, is that this value here you substitute in. And now we just need to work that out. So simplification, this just becomes 8 plus 1 is 9 minus k, and this is just 4 on 3. So the bottom will become 3k, which I just multiplied over here, right? And that remains as 4. And now we just want to expand that. So 4 times 9 gives us 36. 4 times -k, -4k. Yeah? Add that to that side, becomes 7k. Divide both sides by 7, and you get that k is less than 5.14 for this to be true. Now, let's consider this in terms of the values. So that is not a whole number, so you just consider values on either side of it. So less than 5.14 is just 1, 2, 3, 4, 5, yeah? And we know that by multiplying that up there, that tk plus 1 is greater than that for these values. And substituting in 1, you get t2 is greater than t1, substituting 2, t3 is greater than t2, so on. Substituting 5, you get t6 is greater than t5. So ultimately you come up with this equation over here, yeah? Now let's consider for when k is greater than 5.14. All right? And in this case, because we flip the sign for that, we also flip this sign. So that's why it's become tk is greater than tk plus 1. And that only applies for 6, 7, and 8. So now substituting that in, you just get 6 is greater than 7, 7 is greater than 8, 8 is greater than 9, all right? And now, remember how previously we put it together? Yeah, so the same idea, if you put that over here, you can see that the 6th term is greater than either side. So therefore, T6 must be the greatest coefficient, okay? And we just substituted back in to the general term, but the only difference is that here, instead of having 2x, because we know that x equals to 2, we substitute in that 2 again there, all right? So those are your two differences, that 2 being substituted in and that 2 being substituted in. So knowing that T6 is T5 plus 1, so that was K equals to 5. 8C5, 3 to the power of 8 minus 5, and this was 2 times 2 to the power of 5, yeah? Put that into your calculator and you should get this number as your numerically greatest coefficient. Now, it doesn't apply in this case because it's positive, but even if it was a negative number, you still know it's your numerically greatest coefficient, right? Because when it says numerically greatest coefficient, it gives no preference to signs. All right, so just remember, the difference here is we found out that x equals to 2. So all you need to do is substitute that into your equation for the ratio. And just because that says x here, and I know in our first slide we said it was by on ax, it doesn't matter. It's just the term to do with the second term here and the term to do with the first term there. That's all you need to consider. Great, so that was question 5.